Hi everyone, myself Chandrakala T. Today we are going to discuss about the topic that is analyzing abnormality while driving to avoid accidents under the guidance of Pampapati BM, Assistant Professor, CSC Department. These are the contents that we are going to discuss in this topic. First is introduction. Traffic safety requires analysis of not only accidents but also drivers' records. The level of stress for drivers will have a great impact while driving. The main reason for high accident frequency is due to high driving frequency. So, driver stress may affect driver's performance and increases the possibility of occurring accidents. Many innocent lives are lost due to these accidents. Sometimes accidents may occur due to combination of reasons from bad visibility to unsafe road design. But here we only take into an account of driver's mistakes due to stress, which increases of possibility of occurring accidents. These stress levels cannot be measured physically, so the abnormalities such as ECG, eye blink, heart rate, etc. can be monitored from the sensors while driving. These parameters might be helpful to observe the driver's distraction area and problem statement. Number of traffic accidents counters measures helped us in reducing the number of accidents occurring annually. Here, errors are the main causes of accidents. Drivers for failing to follow the safety measures, precautions like overloading the vehicle beyond the vehicle capacity would also cause the accidents. Prior warnings are to be given to the drivers to avoid the accidents. Objective. My main objective is to help the drivers from accidents by giving prior warning to the drivers so that they can take necessary precautions and thereby reducing the accident rate. Implementation. In the existing system, there are no devices for the detection of drivers' abnormality, and so accidents are happening at a very high rate, resulting in massive loss of life. The researchers state that road environmental factors are only 2.6% for accidents, whereas human factors are at 92%. So, this device will detect human factors that are responsible for accidents and helps in reducing accident rate. This figure shows the architecture of testing device. This system consists of an heartbeat sensor and an high blink sensor which collects data from the driver which requires to be shared and analyzed. These are the sensors used. Implementation. The data collected from device is analyzed using R programming language, which is an open source programming language commonly used for data analysis, statistical computing, machine learning algorithms, and scientific research. So, the statistical analysis and graphical representation can also be made. Multidimensional data is used for the collection of large amount of data. This includes two methods. One is unsupervised learning method and other is clustering. In this paper, K-means algorithm is used for clustering. It keeps grouping the similar data under the conditions like 74 to 76, 72 to 74, and so on less than 68. A clustering. The best example of unsupervised learning is K-means clustering. Here, in this clustering, the data are grouped according to their similarities like 74 to 76, 72 to 74, 70 to 68, less than 68. The steps to be followed for the iterated search. The centroid needs to be close to the data points. A new centroid should be calculated for each cluster. B classification. Here, SVM support vector mechanism mission is used for classification, which is supervised learning model. SVM it is a linear model for classification and regression problems. The algorithm creates a line or a hyperplane which separates the data into classes. They also include associated learning, algorithms, and regression analysis. R programming is used to implement it. SVM mainly needs to have a pair of coordinates x, y. Let's q equals to q1, q2, and so on qn be the set of data points, and p equals to p1, pv2, and so on pc be the set of centers. Cluster centers are randomly selected as CE. The distance between each data point and cluster centers are calculated. The set of data points to the cluster center having a minimum distance from the cluster center of all cluster centers is assigned. Repeat from step 3 if no data point was assigned and then stop. Implementation. The real-time data are processed from NetBeans as an Excel file to our programming studio for data analysis. In our programming, clustering and classification algorithms are processed for normal or abnormal conditions of the driver. For clustering, we used k-means clustering, and SVM algorithm is used for classification. The driver's data are stored in public cloud server, namely CloudMe. The real-time data can be monitored by the travel owner, travel agency, bus service center. Conclusion. This paper mainly helps the drivers from accidents and warns the drivers by the prior warning so that they can take necessary precautions. In this paper, we reviewed the different methods available to determine a driver's drowsiness state. Two sensors, heartbeat and high blink sensors, are used to detect driver's health condition. Future enhancement. In future, it would be interesting to investigate the availability to ability to detect drowsiness using a combination of physiological signals and other measurements. Output collection of data. The data is collected from both the sensors is taken into the Arduino Uno is in a real-time basis. The data collected from the sensors are captured using Arduino Uno. Data processing. The collected data is taken for further processing using NetBeans. This concrete class then interacts with a dynamic link library file through the Java native interface. One serial port object has been created. Communications through the physical port are conducted through standard input stream and output stream objects. These streams send and receive information as bytes, integers, or arrays of bytes. Storage of data. The collected data is stored in SQL log for further retrieval. Further, the data is stored in the cloud storage, CloudMe. Sharing of data encrypted. The data is retrieved and shared using the CloudMe for further use. Data store will be encrypted and decrypted as well in CloudMe. Decrypted data. Analysis in R. The analyzed result is viewed in the UI created in the form of this graph. The analysis is done in R programming and it is clearly shown in figure 5. The clustering and classification is done in R Studio and the analysis is shown. Here are the references. Thank you.